Hi everyone, in this video I'll be explaining what is arithmetics and we'll be exploring the foundations and applications. So first of all, what is arithmetic? Arithmetic is a branch of mathematics dealing with the properties and manipulation of numbers. The word arithmetic comes from the Greek word arithmos, which means numbers. Arithmetic is fundamental to both practical applications and theoretical developments across a wide range of disciplines. So now we're going to talk about all the properties of numbers. First, we have 0 and all natural numbers, which are 1, 2, 3, 4, 5, etc. And these two groups form the whole numbers, which are basically all numbers without a decimal, starting from 0, so 0, 1, 2, 3, 4, 5, etc. Now, all whole numbers and all negative integers make up all integers which range from negative infinite to infinite but have no decimals. And these integers with fractions, which are numbers, but basically the result of a division between two whole numbers, give us all rational numbers, which are all numbers that can be written in a fractional form. Now, all rational numbers and all irrational numbers, so for example, pi or root of 2, make up all real numbers, which can be put on a number line. And all real numbers and all imaginary numbers, so imaginary numbers are basically numbers that come from I. So I is the result of the root of -1. So for example, 2 times I would be imaginary because -1 doesn't have a root. But mathematicians used I to represent the root to kind of still give some answers even though it doesn't really exist. Now real numbers and imaginary numbers make up all complex numbers. So basically all numbers we know about till now. Now, numbers can be manipulated in many ways. First, there's the four basic operations, so addition, subtraction, multiplication, and division. After, there's also roots. So roots are a way to find the base of an equation when you already know the exponent and the final answer. Now, exponents, on the other hand, are basically the number of times the base is multiplied by itself. For example, 2 to the power of 7 would means 2 would multiply itself 7 times to get a number, which is 128. Now, logarithms are a way to find the exponent while knowing the answer and the base. Basically, logarithm of 8 base 2, for example, would be 3 because the 3 to the third power would be equal to 8. Now here are some examples of what I just said before. For example, addition would be 4 plus 7, subtraction would be 11 minus 4, multiplication would be 4 times 5, division would be 20 over 4, exponent would be a number multiplied by itself repeatedly, so 4 squared would be 16, because 4 times 4 equals 16. Root would be multiplied by itself produces the original number. So for example, root of 16 would be 4. Square root of 16 would be 4 because 4 times 4 gives us 16. Now the logarithm is how many ways one number multiplied together to make another number. Basically, we're finding the exponent. So what is the log base 4 of 16? Now, it's 2 because 4 to the power of 2 gives us 16. Now, some of the operations I just discussed about have some properties. For example, addition has a commutative property. You can change the order and it doesn't affect the result. Multiplication also has this property. Associative property is changing grouping does not affect the result. So for example, 6 plus 7 plus 8 would still be equal to 6 plus 7 plus 8. Distributive property means distributing the multiplication over addition or subtraction. Now, for example, this works for multiplication because take 5 times 3 plus 7 in brackets. You can also write it as 5 times 3 plus 5 times 7 because the the multiplication can distribute itself to the 3 and the 7. Now, identity elements are numbers that do not change others under an operation. For example, 10 plus 0 still gives us 10. 5 times 1 still gives us 5. So every operation has a specific order. Now, first of all, there's the brackets represented by two arcs that have the first level, which means they're the highest priority when it comes to operations. Next, there's the exponents, which also include roots and logarithms, and they have the second priority, which means they come right after brackets. Now, the third level belongs to juxtaposition multiplication, which is a bit controversial because some people don't really include it while others do. But basically, what that means is juxtaposition is the implicit multiplication created by placing two things next to each other, not with the two numbers. For example, 3a would be a juxtaposition multiplication, but 3 times a wouldn't. At level 4, we have some unary operations. For example, we have sine, cosine, factorial, and negative. At 5, we have multiplication and division, which change based on which one is at the left and which one is at the right. We have to follow the rule from left to right, which means the one at the left has the priority. Now at level 6 we have addition and subtraction, which follow the same rule as level 5, so we have to follow the rule from left to right. So all data can be measured with specific units. There's 7 fundamental measurements, and these are the base units from which all other units are derived. These are used to measure various physical quantities and form the foundation of the metric system. Here's the 7 base units measurement. First, there's length, which unit is meters. Then there's times, which is measured in seconds. Quantity of substance, which is measured in moles. Electricity, which is measured in ampere. Mass, which is measured in kilograms. Temperature, which is measured in Kelvin, because Kelvin is the original one, and Celsius and Fahrenheit all derive from it. And brightness, which is measured with candela. Arithmetics are all essential for everyday tasks. For example, it is used in probability, statistics, geometry, algebra, and even harder concepts in mathematics such as calculus, progression, permutation, and combination. Here is a concept map of arithmetics with all the numbers at the bottom, all the connections at the left, all the computation at the right, and all the measured datas at the top. Thank you very much for listening, and hopefully see you next time.